Hi, my name is Marcin Krzyżanowski, and as you could read in the title of this video, and you can read it now on the screen, in this tutorial I would like to show you how to design underfloor heating installation in InstalSystem 5 package. But before we go to the right lesson, first I would like to show you where you can find some information about us, about InstalSoft, and where and what kind of technical support you can find also in internet. So first, maybe let me show you our web page. This is instalsoft.com. You will find here also other language versions of our web page. This is current layout. We are working on the new one, so soon you will find a different view and different version of our web page, but the contents I think will be more or less similar. And first on the main page, you will find some news. For example, in the newest version 20.0, you will find new BIM modules. You can read something about them right here. And there are different tabs. For example, you can read about the products. And also here, you will find a tab, trainings and advices. And there you may read something about trainings we do, mostly in a kind of online meetings, online workshops. So if you would like to be, if you would like to attend it in that kind of training, you will find all required information right here. And below you will also find what plans, what trainings are available. And for example, we will today work on a similar plan. So generally, we will try to design underfloor heating installation on two different examples. And if you would like to have some private training for you or for your teammates, for your office, you can also order that kind of training just by sending us email with some information. So this is our web page. We also have our YouTube channel, and there, as you can see at the top of the main page, there is some contents in the Polish PL, but if you scroll it down, you will also find some videos in English. These are some free videos about InstalSystem 5. Next, we have webinars, and in this playlist you will also find tutorials. So this video you are watching now will be also available probably right here. And we have also scheduled another webinar about heat loss calculations. So soon you will also find two more positions right here. Novelties in releases. These videos present the biggest, the major changes in next updates of our software. And for example, in the last one, 20.0, you will find our new BIM modules. And below you can see that there are some videos in German, in Italian, and in the nearest future we would like to also add here some videos in Chinese and also in Russian. There you can see also on our webpage that we've got a German version of our webpage. This is global in English, Bulgarian, Chinese, Lithuanian, Polish, Portuguese, Romanian, and Russian page. And finally, we have our HelpSystem platform. You have access to this platform directly from our YouTube channel. If you click here on this button, HelpSystem, you will see in the next page HelpSystem. But you have also access to this help system directly from the program. I will switch for a brief second to our package manager. This is package manager, and it looks very similar in different software versions, customized software versions. The layout, the graphical layout may be different, but the buttons on the left side are the same. And there we have help button. And first there's a tab technical support. And if you have a problem with the license, with activation, you can use this form. It will be sent to us and we will be able to help you to solve your problem. Or you may use this button, ask question, report a problem. If you are working on some project and you got to some point you cannot solve the problem by yourself, you can send us the project file and describe what is the problem. But also here we have online help, and this is the same platform. It's docked here in this window. And finally, you can just use your browser, enter, and you will find it also this way. So it may be open on the Polish version, but you can switch it to the right one. And in our help system, you will find a kind of lessons. This is that part. And for example, this one, what we will do today, you will find right here, designing of radiant heating floor and wall installations. And in these articles, you can find the contents all on the right side, and step by step, you can try to make the project by yourself by going through all the stages. So remember about our YouTube channel, remember about our help system, and remember that you can also order a training. And if you are working on some project, you can also send us your project file directly from the program. And now I would like to show you what is the plan of this tutorial and what are the typical stages of the project design. So what stages you need to go through usually if you want to design underfloor heating installation. So this is the first stage, the first step, preparation of building structure. And there are two ways, two scenarios of building structure preparation. The first one, simplified, where rooms are represented by cuboids, as you can see on this little preview. And in this case, we can do it very quickly, but we cannot calculate precisely heat losses. Heat losses need to be estimated or imposed. Estimated using the heat loss coefficient, or just imposed manually. Second scenario, with complete building structure. And this preview, this nice looking building came from IFC file. And this complete building structure must include all required building structure elements like walls, floors, windows, slabs, floors, etc. And in this case, when the building structure is complete, we may calculate precisely heat losses using some extra program module. It's called heat loss. And today we will start with the simplified method. I will show you how to prepare that kind of building structure as a base for further installation design. But I will also show you how you can use that kind of model of the building. We'll not go through all the stages to prepare that building. I will show you where you can find information about that stage, but we will also use it as a base for our underfloor heating installation. Stage number 2, setting default data for the project. Using some window in the program, it's called general data, you can enter, you can modify, or just browse some general data for the project. Like you can choose manufacturer and the system for underfloor wall or ceiling installation. You can choose some basic elements like manifold, thermostats, and you can set the parameters, most important parameters like supply temperature, temperature drop, maximum pressure drop. Later in the project, when you are on some stage of project implementation, you can modify these parameters, and it's also very useful if you want to change the assumptions, you want to change the parameters, you want to change the system. You don't need to do it by clicking and selecting all elements in the project. You can just use this general data window. Next stage is graphical edition of the project, and usually we need to indicate heating cooling zones. Next, we need to put somewhere the manifolds and connect the manifolds with the heating zones using the pipe fits. When it's done, we can go to calculations, and after the first calculations, we can check the results. Usually in this yellow window, we see some messages, some diagnostics, and in the next step, we can, if we want, or sometimes we need to, change the parameters. So there on this example, you can see how or where you can change the supply temperature for the radiant installation, where you can change the pipe spacing and temperature drop. Many parameters are determined automatically by the program, but you have full control on these parameters, and you can change them according to your knowledge and to your technical sense. And finally, when you've obtained acceptable results in scope of thermal calculations and the whole system is hydraulically balanced, finally you can prepare the drawings for the printout or to export to DWG, PDF, or IFC file. And these 5 stages of the project implementation are the typical one. And now we will start with the first stage. Let me close it and let me go back to Package Manager. So first I create a new project, choose the project template, a default one in this case. And as I said, we will start with the preparation of simplified building structure. We will import our typical DWG file, and using this DWG file we will create rooms as the cuboids. Program is already started. It's right here. And starting with 2D editing, we use this underlay. And first we may just import DWG file. There's a button import underlay. And here you can see what formats of files can be used in the program. Next to DWG file, we've got also bitmaps, other graphical formats, but also PDF file. DWG files are mostly useful, but they are really also very comfortable because we can use snapping mode for these files. Okay, so I'll open it. And this is the file we use on most of our trainings. There are 3 levels. There's also cross-section of the building and side views. And what we can do about it, usually we need to at least check the scale of the drawing. You can use this measure right here, this value, just to, let's say, roughly check if the scale is correct. But you can also check it more precisely if you zoom in some part of the drawing. For example, this is some opening. You can use this tool to check that size. As you can see, it's 90 centimeters, so the scale is correct. But in some cases, the scale at the beginning may be incorrect. Let me show you this result. Let's say that I will choose 1 centimeter, the basic unit. First of all, as you can see, the whole drawing, the width of this drawing is only 2 meters. And also, if I check that the same size, program will show me that this is, well, 1 centimeter. So that's the information that the scale is incorrect. You should choose another unit and check it once again. For our drawing, the proper unit is 1 meter, and we can leave it. If you are using as a background, as the underlay, not a DWG file, but for example PDF file, you should use another different method of scaling the project, this button. When you click on it, you will, in the next step, you will be prompted by the program to indicate 2 points and then to enter distance between these 2 points. So the method is very, very easy, but you need to do it more precisely. Okay, so we've got the WG file, and now we've got only one worksheet with one level. We'll create 2 more in the next step. First, what we can do with this drawing. First, we can limit the visible area just to one single story, just to see the basement. There is a button, visible underlay area. You click here, and click here. You will limit the view just to that single story. And what you must do always if you have the building with more than one level, you need to put that reference point somewhere in the same point on all levels. As you can see in the description right here, a hint, a reference point allows to establish correct graphic relations between stories located on individual sheets inserted at a common point. Maybe later in this tutorial I will paste in some point of this video screenshot with correct and incorrect situation. What will happen if you forget about that reference point? Okay, so we have it, and now I would like to create 2 more levels. First, I need to go to General Data, and on this tab, Storage Management, I will create 2 more levels. Add the first one, add the next one, and I should also change all these parameters of particular stories, the height, ground elevation, floor thickness, and so on. You can use that preview let me show you the whole drawing once again. Cancel limitation of visible underlay area. You can use all these dimensions from the cross section to set all these parameters. But because we will not continue this project using that underlays, I will skip that part and I will just import 2 more levels and 2 more drawings, so you will see the complete building as a base for underfloor heating installation. So I have created 2 more levels, and now I will also see here 2 more levels. Let me again limit the view. And now I go up to the next level and again import underlay. I choose the same file. This time I need that intermediate level. So limit visible area, and don't forget to put reference point. And finally the last one, the second level, again the same file. Again I will hide other stories and put the reference point. Okay, so now we already have the underlays. I will save the project. Simplified rooms cuboids. Okay. And I'll start with the basement again. And now I will draw the rooms. First, choose Construction tab, and here you should use this icon, Room. If the rooms are represented by rectangles on this plan view, you can do it very quickly by clicking on 2 points in the diagonal in the opposite sides of the room. Click here, and one by one we will do the same on this story and also on other stories. Okay, that's it. That's it. We can also check it on a 3D view. You can see these cuboids. And that's all we need if you want to design the installation using the values of heat demand estimated or calculated from the heat loss coefficient, or just by imposing this value. So maybe first let me show you where you can change that coefficient in the general data window. On the room data, there is a coefficient, and default value is set to 55. You can change it right here for all the rooms, or back in the drawing, if you click on that round label of the room, you can change coefficient directly right here, and you can see that the value changes. Or you can just choose this variant, user specified, and just enter the value of required heating output. And having that building, we could already start to design our radiant heating installation. But we will stop right here because next I would like to show you how you can design the installation but using complete building structure, in this case from IFC file. Now you can see on your screen complete example of complete building structure. This one comes from one of Open BIM standards from IFC file. And I will not show you the whole path of creating that building and calculating heat losses because it was and it will be a subject for other webinars. But I will show you where you can find materials, where you can find information how to do it if you would like to do it by yourself. So first of all, you don't need to have that kind of model building in IFC file, because you can also create complete building structure directly in the program, choosing proper elements from construction tab. On construction tab, we've got all the basic elements like wall, roof, door opening, window, recess, slab opening. Using all these items, you can do it by yourself. If you would like to see and check how to do it, please first check our webinar. It's right here. This webinar about preparation of building structure. It was recorded by my colleague Rafał, and here you will find the path, all the steps you need to do to create that complete building structure. As I said before, we have already scheduled new webinar about heat loss calculations, and you will find it also right here. And if you would like to find out how to get such a nice looking building from IFC file, please check that webinar. Also, you will find proper articles in our help system. Preparation of building structure, for example, right here. And here you will see these two scenarios, how to create simplified and complete building structure with, as you can see, some descriptions, screenshots, and also some short videos. And there's also a lesson, calculation of design heat load of rooms. So if you would like to do it by yourself, repeat it, or use some other files to check it, to learn the program, you can use our help system articles. And in our project, we will design underfloor heating installation in the ground floor. But before we start some graphic edition, we will go directly to the second step, usually second stage of the project. So we will check general data and set some parameters. Here is general data window, and we should start with the project scope, and we should switch on heating systems. When you click on this checkbox, you will see more tabs, and we can browse one by one, starting with the catalogs. There in this window you will find all databases of products available in your program. Depending on language version you use, you will find here different contents. This one is valid for English version. And using these filters, you can display just some types of databases, some types of products. For example, let's check what Radiant systems we have in this configuration. And you can see different manufacturers right here in the list. And there's also another filter on the right side. You can display just manufacturers, so customized databases, or you can display just neutral databases. So these databases will not indicate any producer. There is also some extra filter for the German market or for the Austrian market VDI databases. So in this window, you can just select manufacturer or the system you would like to use in your project. We will use some neutral databases which are already in the project, so I don't need to read anything else. Another tab, climatic data. It's already been used by the program during calculations of heat losses, so generally we may skip it. And maybe let's go directly to this group of tabs, thermal systems. Starting with sources. There, for example, you will find default source use. Right now we've got just selected heating systems module, so we cannot choose or change between any other variants. But let's switch on just for a minute cooling systems. And now you can see that you may choose between 3 different variants. Default source use heating, heating and cooling efficiency, and cooling. The second variant means that if you will design radiant heating installation, program will additionally also calculate cooling efficiency. And the third one means that if you choose it, program will size all the parameters, will determine all the parameters to cover, first of all, required cooling output. Okay, sources. Next, we can choose medium. And in the next field, you can see the supply temperature. This is supply temperature of the medium of the source. So if you have in your project not only radiant installation, but you have also radiators, this will be the supply temperature in the installation. Supply temperature for the radiant system will be optimized or can be imposed right here in this set of fields. As you can see, by the default program proposes to optimize supply temperature. We've got 2 different criterions. The default one, minimum investment costs, and the second, heat output and pressure drop. This one, what you may expect choosing this one, you may expect the program will try to use the biggest possible pipe spacing to have the lowest quantity of the pipes, to have smaller manifold, so generally to reduce the investment costs. But in return, you may receive higher supply temperature, required higher supply temperature on the manifold. You can also impose supply temperature by choosing the second variant. And in our project, we will leave first the program to do it automatically, and then we will check it, and if necessary, we will change that calculated value of supply temperature. We will not use in our project flat stations, so we may skip it. We've got here also visual connections which are especially useful in case of quick estimations and quick calculations of radiant systems, and you will see that scenario also in our project, because we will start with calculations using virtual connections. Types and default data. You can choose default pipe type in our distribution network. Also insulation, ambient temperatures in the heating and cooling mode. And we've got also few more positions, few more fields where you can choose different kinds of or different types of valves if they are used in the project. Pipes and insulation sizing options. You can see the default pipe we have selected right here. And for this pipe, you can check the parameters like minimum selected diameter by the program, maximum velocity, and the maximum unit pressure loss. We will focus on these tabs because we will design floor systems in our project. So let's take a look on this tab. This is a kind of neutral catalog. So you will find in this neutral catalog most typical systems. Default system, Tucker, clip rail system. Also you will find here some example of dry boards, floor nap systems. And we will choose the most common system with Tucker. Structure panel. You can choose structure panel depending on the catalog and the manufacturer. You will find a different selection here. For example, in this case, you can choose between different thickness of the structure panel, but sometimes you will find here different variants according to density of the insulation. Default pipe type. Pipe length pattern, the most typical one, spiral, or sometimes called also snake, double and single pipe meander. And here you can decide also if the program should automatically after each calculations generate loops drawings. And as you can see, by default it's selected. So if anything changes in the project and it results in some different arrangement of the pipes, after each calculation program will regenerate the loops drawings. Available spacing in occupied and in peripheral zone. And you can just select, for example, the biggest values. Also, you can offset the effective area of the heating floor from the wall. And below, you can also see what is the screed, what is the heat transfer coefficient. And below, we have pipe fits arrangement. Pipe fits between manifold and heating zones are arranged or can be arranged automatically, and there you can choose between some variants, but we will skip description of these variants right now. We will check it directly in the project when the pipe fits are generated. On the right side, we've got operating parameters. Maximum pressure drop in each circuit. Usually it's about 25 or 30 kilopascals. Maximum working load in kilonewtons per square meter. Utilization of pipe fits. If the pipe fits are passing by some floor, they produce some output, and by this value we can estimate what value of transferred heat is used in some particular heating floor. Next fields, temperature drop. minimum and maximum value of temperature drop in each circuit. And using these values, using this brackets, program will determine and will propose some optimum value to obtain required heating output and also not to exceed this maximum pressure loss. And there is also one very important parameter, covering of the floor in the installation. And as you can see, there is some arrow. You can click here and the program will switch back to room data tab, where you will find different room types. And for each room type, you can choose proper covering. We will use it and we will do it directly on the plan view. So I will skip that selection right here. And let's check other tabs. Wall systems. We will not use wall heating in that project. So, but as you can see, it's very similar to floor systems. And it's also worth to mention that in the program you can design ceiling systems. Also, another module in the program allows to design radiant installation with some prefabricated panels. And finally, we get to that tab where we can set manifolds. Also, this list of manifolds comes from our neutral catalog, which presents some typical solutions. And let's choose, for example, this one manifold with flow meters. With the manifold, we can also choose some additional accessories. It's called manifold set, and there is some list of typical accessories. And for our project, because we will have in this quite a big building, we will have more manifolds, and it might be very useful to have the possibility to control supply temperature on each manifold. We will use mixing set. So when I selected right here and later when I put the manifold on the drawing, each manifold will be provided with that additional mixing set. Manifold cabinet type, we may leave that one, the default setting concealed manifold cabinet, and control systems with the thermostats. Another tab with coils. On this tab you can limit the maximum length of each circuit. We have that 16mm pipe, PEX pipe, and we may check what is the maximum value of the circuit. We may leave it at 130, or you may increase or decrease this value. There are some additional options and they are mostly concerned with drawings of the pipe loops and calculations according to coil length on the drawing. Take into account in calculations computational loop length or drawing loop length. As I said, program automatically generates loops drawings, and depending on the scale of modifications you introduce on the drawing, you can choose between these two options. Pipe loops drawings manner, compact arrangement if there is no space for standard pipe spacing, or leave empty. Also, it concerns the pipe loops drawings. In some cases, the program leaves some empty space inside the spiral because there is too less space to to fill it with the pipes, and you can decide if the pipe should be compacted or that empty space should just live in the project. And these are all the tabs we need to check or we need to modify if we design radiant heating systems. We can save the project. And we can go to the next stage and we can start to edit the plan view. The whole building structure in this file has been created and heat losses have been also calculated. We can check the heat losses values here in these round labels of the rooms, and we can also check results in some additional window. Right here. For example, this is the total value of heat load of the building. And then one by one we can also check what are the values for particular rooms. Before we will start to design underfloor heating installation, let's check the 3D view, and maybe let's divide the screen into two parts. On the right side we will see this 3D view, on the left side 2D view, and let's maybe hide other levels, and we will just limit the view to the ground floor. So here I will uncheck basement, first story and second floor, and as you can see you can go further and hide some particular types of elements in the project. And now, having that view, we will be able to check to verify that underfloor heating installation. Okay, I will close it. And all in all, I would like to have that installation on the entire area of the ground floor, but we will start with just part of it. We'll start with the left side of the building and with these few rooms right here. So first we should choose the proper scope of the project, radiant floors and walls. And in this scope you can check what icons and what functions we've got on the ribbon. First, as it was mentioned in one of the pages with subsequent stages of project implementation, first we need to introduce heating zones. And we can do it in a few different ways. When you click on this button, you will find three functions: floor auto, floor manual, or floor in each room. By selecting this function, we would introduce the heating zones into all the rooms, but now I would like to just limit it to 1, 2, 3, 4, 5, 6, 7, 8 rooms. So instead I will choose this function and click one by one to all these rooms. Okay. And in the next step, I need to put somewhere on the drawing the manifold. Manifold is right here. I will put it here, rotate it, and put it inside the wall. Maybe somewhere here. Okay. And for the first calculations, we will use virtual connections. So we will not complete the whole installation with source, with all the pipes, all the fittings. We will use that mode with virtual connections. If this checkbox is on, after placing heating zones and after placing the manifold, you can already calculate the project and check the results. But before we do it, let's check data of one particular heating zone. This is a label of the heating zone. When you click on it and display data table, you will find all data that you can change for each selected heating zone, and we can select one or many by holding Ctrl key and clicking on the label. So let's take a look on the data table. Symbol, automatic division of heating zone. As you can see, it's on. It means that the program during calculations, if it will be necessary, program will divide the heating zone on required number of separate loops. Effective area, area that will be taken into account to bill of materials. You can also introduce some value, some space or some area that is occupied, for example, by kitchen cabinets. And you can also offset the heating zone from walls. Technical data, to what manifold is connected this particular zone. In the auto mode, program will do it automatically. And later on, we will also draw the connections directly. So it will be connected not by virtual pipe fits, it will be connected graphically. And the next one, very important field, heating cooling zone type. Standard one, the default one, is just a separate circuit connected with the manifold. The next one, heated cooled by pipe fits. There will be no extra loop connected with the manifold. This type of heating floor is just heated by pipe fits passing by and connecting other rooms without pipe fits and multi-circuit. Next, we have criterion of division. Just a minute ago, I've said that program can divide the heating zone on required number of loops. And there you can choose between two criterions. Either obtain equal pressure losses or obtain equal areas. And here below in the table, you will also see some additional information, what it means. Equal pressure losses and loop lengths are equal plus minus 5%. So there is some tolerance for the results. And if the program needs to divide the heating zone, you can also indicate the direction of division. There is some hot point, looks like scissors. When you grab it with the left mouse button, you can move it like this. And don't be deceived by the number of lines you can see now in the preview. They don't indicate number of heating floors, they just indicate the direction of division lines. So in this case, I will put the scissors on this edge, and I will do the same here, here, Okay. And that's it. So the next one, number of heating cooling areas. In this mode, this computer icon means the program will calculate it, but in some cases you may decide to impose the number of floors or circuits, and you can do it right here. The next field is about floor buildup. There you can decide about construction of your heating floor. In this auto mode, program will determine the thickness of the insulation to obtain that minimum required by EN 1264 standard heat resistance. And in some cases you can switch to manual mode and increase the thickness. You can also here change the covering, you can change the thickness of the screed. So anything what concerns the construction of the heating floor, the layers of the heating floor, can be changed in this window. Covering, let's do it like this. I will select all the heating zones, maybe like this. You can do it also using project browser, and I will change the floor covering to ceramic tiles. Okay, next few parameters, maximum pressure drop, screed. You can also introduce peripheral zone, and let's do it, for example, here for this room on this edge, but maybe we'll decrease the size of it to 60 centimeters. And other data, some of them come from general data. As I said, when we were browsing general data, many parameters can be changed individually after selecting the heating floor, but we will leave it. And I think we may save the project, and using these virtual connections, we may go to the next stage and for the first time run calculations. And this way we have reached another phase of our project. We can run calculations. You can launch calculations by clicking on this big button, this big calculator. This way you can quickly calculate all the modules. In this case, compute the building structure, calculate heat losses, and also calculate heating systems. If in your project was also tap water installation, you could also calculate this module. So this big button allows you to quickly recalculate all the modules, and using these smaller icons you can just recalculate one single module. You can also control the scope of calculations by selecting or deselecting these checkboxes. So first we will click this big button and we will wait for results. You can see the progress of the calculations, computation of building structure, then you'll see some heating systems optimization, and after a few seconds we will get results. There we have one error message about exceeded pressure drop on a valve. It is probably caused by not enough regulation provided by valves on or on flow meters. So maybe let's first change the manifold
from this one to this one with balancing screws, and let's calculate it again. Okay, and now we don't have here any error, no red color under this button, no errors here in the list. These messages with this yellow triangle, these are warnings, and the blue circle is a hint, and you can check also the priorities of messages right here. Errors are most important. If any error is indicated after calculations, you need to eliminate it to get the results. There are also warnings, but warnings don't block the calculations. You should always check the warning, but this is just some situation which may be problematic, but can be accepted. And hints, the lowest priority, they only inform you about some input data, usually in the project. So let's take a look on our drawing now. Maybe let's click on the printout, and you will see that in each room, in each heating zone, we already have drawings, loops drawings. So generally this project has been calculated. We get some results. We will check them right now. We may control the list of messages in this diagnostics window, and we get some warning that for some rooms 0% of required output has been provided, and these are the rooms where we didn't put the heating zones. And for one room from this we've already designed, we see that something like 90% of required output has been provided. So maybe we can change some parameters to improve that or to increase the output. But before we do it, we will draw the pipe fits. But maybe let's first check also the results on the drawings, where you can check the results. Let's take one of the heating zones, maybe this one. First, in the label, when you check the label, you will see the distance between pipes. You will see the total length of the loop and obtained heating output. This is what we need, and this is what we have obtained. So as you can see, 100% coverage. If you want to see more data, you can put the mouse on the label and you will see more detailed results about mass flow rate, about velocity, pressure drop, supply temperature, and few more parameters. Same for the heating zone. You can see more information about the construction of this floor. And we have many detailed tables with results, starting with general results, radiant heating general results. Here, for example, on this tab, you can check the parameters of the manifold. One manifold on ground level, number of circuits, obtained output, output lost through the floor, return temperature, some average value, also average temperature drop, mass flow rate, total value of mass flow rate, required minimum pressure difference, resultant pressure difference, and total pipe loops length. The next tab is more detailed. Here on this tab you can check one by one all the loops and verify their parameters. More interesting tabs are here, for example, room charts. These are some special pages dedicated to radiant systems where you will find some preview of the heating floor in this particular room, cross-section, information about covering, about the area, pipe spacing, pipes, pipe arrangement, and coils length, and also to which number of outlet on the manifold it should be connected. For each room you will find separate page with similar information, with similar drawings. And another extra printout is manifold board. There you will find information of all loops, all pipes connected with the manifold, about pressure drop, obtained output, and valve presets. And below on the next page you will find some pictures of the manifold cabinet, accessories, and the list of items, the list of accessories that should be mounted together with the manifold inside the manifold cabinet. And finally we can also check list of materials. Starting from top, pipe, how many coils we need, fittings, system plate, some insulation, manifold, some set of valves, heat meter, and few more accessories. So as you could see, we could calculate this project very quickly with simplified building structure and with just selecting heating zones and placing the manifold without precise drawing of pipe fits and all other typical elements of the installation. We can very quickly get complete thermal and hydraulic results, and we can get list of materials. But now we will complete this drawing with connections between the manifold and all the heating floors, because I would like to show you how you can quickly do it using our extra tool, pipe fits route. First, I will make a slight modification right here. There is the manifold, and because there will be many pipe fits passing by this room, I will change type of this heating zone from standard to heated cooled by pipe fits. After that, I will delete this loop. And now I will show you how you can quickly connect and draw all the pipe fits to connect heating floors with the manifold. First, you need to click on this icon and click somewhere between the bars, somewhere in the axis of the manifold. Can be right here. Then go to the left, the edge of the first zone, click right here, and you can go like this. Connect the first standard heating zone. This symbol informs you that that section of pipe feed route was properly connected with this heating zone, and in a similar way we will connect all other heating zones. Once again I click here and start from this point, go to the left here, and then I go up to connect all other heating zones that are above. So first here and next here. Okay. Then I will start here and go to this one. You should always pay attention if this symbol is displayed, because it indicates and informs that this section is connected to this zone. If you don't see that symbol, it means that you should probably slightly improve the drawing to connect it. Okay, so all the zones above the manifold are already connected. So let's go down. And now we will do the same with the rooms and the zones that are above. I start from this point and go down here and to the left here. It's okay. And this way we have connected all heating zones. Okay, so let's save the project. And we'll run calculations again. Okay, it's done. I don't see any red color right here, so it means that it's been calculated properly. And now let's take a look at the result. Now you can see that from this purple line, from these purple sections, program has drawn the pipe fits from the manifold to each heating zone. It's been done automatically, and the best effect, the best result you will get if you switch to printout, because now you will see that the pipe fits, they connect exactly at the edge of each zone, the loop that is inside the floor. So these two different sections, pipe fits and pipe loops, they are connected, and on the printout you will see it as one single pipe, starting from the manifold and going through the heating floor. Also, if you take a look on each heating floor, you will see that the distance between these pipes is equal to the loop itself. And this is the standard way program tries to arrange the pipe fits, crossing through different rooms and different heating floors. Okay, and let's imagine that we want to change some parameters. For example, as you can see, in some of the rooms, this pipe spacing was calculated as 7.5 centimeter, and probably this is result of quite low value of supply temperature. we may check what temperature was optimized and was determined by the program by going back to general data. Here we are back on Sources tab, and now you can find supply temperature here in this control circuits section. It was optimized by the program and it was set to 34.3 degrees. In result, probably because we have exceeded that maximum allowable pressure drop in this and this and in this heating zone, program automatically divided these three zones into two separate circuits. And let's check what will happen if I increase that supply temperature. Instead of 34, let's increase it to, for example, 37. I see different arrangement, but still I can see the same number of heating zones. Let's increase it a little bit more. And now you can see that, for example, in this room and this one, because we have increased the supply temperature and the floor temperature was higher, it's provided higher output, and the flow, the mass flow rate through these two zones could be reduced. And in this result, we have obtained just one loop per one room. So you can also see now how easily and how quickly you can modify some parameters and check their influence on the results of calculations and on results of your drawings. Okay, so let's focus now on this room and let's try to fill that space by these pipe fits passing to other rooms. This heating zone is heated cooled by pipe fits, that's why you cannot see here extra loop. And now we will try to fill it better. Now these pipes are very compacted close to the edge. And I will show you in two ways how you can change this arrangement. First of all, when you select that kind of heating zone, you can change pipe spacing of these pipes in a data table by choosing any other value, let's say 150. And right after that, if you calculate the project, you will see the difference. Now the distance is bigger. We can increase it a little more to 175. Okay. And we can also try a different solution. If you select one or more sections of pipe fit route, you can change manner of pipe fit spacing determination. Description of all variants you will find here, and we will select one of them according to band fill, and using this icon we will indicate the area that should be filled with all these pipe fits. And now you can see the difference, and we can try to do same with this section. Okay. That's what we get. In the next phase, when the project is calculated, I will show you how to introduce manual modifications. So now I will change it a little bit like this, and I will leave it. Okay. And taking that opportunity, I will show you also another alternative way of designing that kind of heating floors with the method that came to us from Scandinavia. Let's save the project. And using one of the functions in the program, we can put all these pipe fits into insulation layer. So they will not constitute the heating floor. They will be below the screed, usually in the polystyrene, in the insulation. First of all, I need to change again heating zone type to standard. And then I may use this checkbox. Pipe fits in insulation layer. And connect pipe fits route to the edge of this zone. And look what happens now. Okay, now it's been calculated, but you can also see somewhere in the background pipe loops inside this room. Maybe let's check again 3D view. And let me hide all other scopes and just leave on the drawing loops so we can see it clearly. The only visible when active. And now if you zoom in this room, you will see that the pipe fits go below the heating floor, and there is separate loop above in this room. So the pipe fits go down into polystyrene, and when they leave this room, they go again up, and then they constitute the right proper loop in next room. And there is extra loop inside this tiny room. So this is another alternative way of designing installation in this kind of rooms. We'll go back to the previous situation. And we have finished this way another phase of the project, and in the next phase we will make more modifications and we will focus on other parameters, change some parameters, and we will check how they influence on results. Okay, so let's continue our project and let's design heating floors in other rooms on this level. We will start with the first room that is on the right side, this one, and taking advantage of this automatically divided heating zones and automatically generated pipe fits, we'll do it quite quickly. We need to first put heating zone inside the room and then connect it to the manifold. We'll use the same manifold on the left side, and we will choose a new section or new route of pipe fits route. So we will start again from the manifold and we'll connect this zone with such a short section. And I will only check where are the scissors on which edge of this zone. I will move it down to the horizontal edge. So if it will be required to divide this zone, program will do it horizontally. And now we can launch the calculations and check results. Okay, it's been calculated. As you can see, program divided it into 3 circuits. There are pipe fits, pipe loops. Some minor changes or improvements of the drawings are required right here, but we'll do it later in the next phase of this project. And now we will focus on that big space on the right side. As usual, first we need to put the heating zone. And that big zone must be first pre-divided. As you can see, for example, here in this zone, program can divide zone, but only in one direction. So in case of such big spaces, we need to first pre-divide the zone, make some smaller parts, smaller zones, and then we may let program to make further divisions into circuits. So looking at this drawing, maybe let's first draw the first division line right here, because here is some opening in slab because of stairs going down to the basement. The division line you will find right here under this button, and taking that opportunity, we will also provide the expansion joint between these two parts of heating zones. So using this tool, I draw that division line right here, and it's already been divided. There is one zone, and on the right side there is another zone. And next I will cut that part here to avoid putting the pipes, the loops, on this opening. This opening we can see also on the right side. It's right here. And if we display basement, probably we will see the stairs. Yeah. Okay. So to avoid that fragment, I will cut that part and delete it. This time I will use just this icon, and we'll do it like this. And delete that zone. Okay. And let's continue. Another division line I will draw on this edge, or starting from this corner of the wall. So now we have 1, 2, 3 big zones. And another modification will be introduced in this room, because there is some library, looks like library, and we've got some shelves right here. And I wouldn't like to put the pipes under these shelves, so I will also cut this part like this.
Oh, sorry again. Okay. And I will change in data table type of this heating floor from the standard one to this one without pipes. And now we need to put manifolds, few more manifolds on the drawing and connect them with these heating zones. First, we can use this room and we can put there the first manifold. And using that short section, I will connect it with the first zone, and again I will check what is the direction of division lines, if it will be necessary, and it surely will be in this case. I will move it down. Another manifold can be placed here, and this one will connect that big space on the right side. And the third one I will put in this tiny room, and also I will put here heating floor and change its type to heated cooled by pipe feeds. And the manifold will be on this wall. And again, using pipe feeds route, we will connect it. So I think all zones have been connected. Let's save the project. Another phase. And let's calculate it. Okay, you can see that two zones have been divided. We can see the pipe fits, but there's one problem probably with this zone. We can see that red color right here, and we can check the diagnostics window. Automatic division of heating cooling zone not possible. So it means that if you make a double click, program will select the zone which it concerns, and we need to solve the problem. You can check some additional article, HelpSystem article in our platform. Some of messages, some of problematic messages you can find in this yellow diagnostics window, they have some additional help. If you click this blue icon with question mark, program will open your web browser on corresponding article, and in this case you will find in this article some typical problems or typical situations that cause that message, and you will find also some tips how to solve the problem. In this case, probably program is not able to divide it because of this tiny wall sticking out, or
going inside this heating floor. Let's make some slight modification. Let's just move these 2 points and let's try to calculate it again. Another modification required, we need to move that scissors probably to one of these horizontal edges. Okay, now the last change succeeded in proper results. No errors. The whole installation has been calculated. We can check it on the printout. You can see in each zone you can find the loops. You can see pipe fits. And you can also check it on 3D view. Maybe let's open the 3D view on the whole screen. And let's use this underlay view, and by holding Control key I will also select 2 more scopes, radiant floors and walls and loops drawings. So these 3 scopes are selected, and now we can check it on the 3D view. You can also check that opening in a slab. And this way we can analyze all the rooms one by one. You can see the library. And if you want, you can also, by controlling the visibility of particular scopes, we can hide the building and the construction elements, and we may just display radiant floors and the loops drawings by selecting these 2 with Control key, and on the right mouse button you can choose the only one visible when active. And now we can see very clearly just the installation with manifolds and all the loops. Okay, and in the next phase of this project we will check how can we influence results with what parameters. So you will find out how you can manipulate with some parameters to improve results, to improve thermal output obtained from the heating floors, and how to influence on hydraulic results. I have prepared some extra board for you because I would like you to be fully aware and conscious of what parameters you can change to affect results of your calculations. And there are mostly 3 parameters significantly influence results. The first one is supply temperature, and you could already see how we can change it in general data. And later I will also show you what you should do if you would like to control supply temperature on each manifold. If you increase supply temperature, you may expect higher heating output, but in return we may also expect lower mass flow rates in circuits, and it will also cause lower pressure losses in circuits, and finally lower quantities of pipe lengths. So by increasing supply temperature, we may generally expect lower investment costs because we will have in the bill of materials less quantity of pipe lengths and also smaller manifold
for example. Another parameter is delta T. This is a temperature drop in a circuit. If you increase temperature drop, you may expect lower values of floor temperatures. This is surface temperature. And it will also cause lower heating output, lower mass flow rate, and finally lower pressure loss. So if in any circuit you have too high pressure loss, by increasing delta T, you may expect reduction of pressure losses in the circuits. And finally, third parameter, we use this symbol, this two-letter symbol VA. It comes from German translation, but this is pipes distance in the circuits. If you decrease the distance between the pipes, so if you compact pipes arrangement, you may expect to receive higher floor temperature and also, because of that, higher heating output, but also higher mass flow rate, and you may also receive more pipes in the bill of materials. And of course, these three parameters, they interfere between each other, so by changing one of them, you should also control the other one. But these are the main rules, and by knowing how you can control it, you will be more aware of results you will receive when you change some of these parameters. And let's go back now to the program. And as you know, supply temperature in general data you can set here. But what you should do if you would like to set different values of supply temperature for manifolds supplying this one big room and different value for this manifold. We need to have in the project some devices that reduce the temperature. Now program assumes that there is some virtual mixer, and this mixer supplies all manifolds in the project. And to reduce temperature, we can use mixer, but we can also use mixing unit on the manifold. And in our project, we will use both, so you will see how you can do it and how you can also draw remaining part of installation, how to do it, how to connect it with installation in the basement. So first what we need, the new element that we will use today is right here, it's mixer. But before we do it, we'll put a riser. This riser connects this manifold with the installation in the basement, so it starts in the basement and it goes up right here. I will connect it like this. And I will switch for a brief second to the basement, and you will see where you can find this riser in the basement. And in the same way, I will draw other risers and connect them with the installation in the basement.
And now we can find all risers in the basement. And I will change in storage management a default distance of pipes from the floor, because they will be in the basement, they will be close to the ceiling. And now, before we will connect it with a source, as I said, for this one manifold, we will use another manifold set with mixing unit. So there will be pump and probably freeway valve. So we will be able to set individually temperature for this manifold. And these three other manifolds, they will be connected with the mixer in the basement. So let me draw remaining part of installation. Okay, so all risers are connected now, and you can see that these three risers, they are connected with this mixer, and the fourth one is connected ahead of mixer. So this mixer will reduce temperature for these three manifolds, and this mixing unit on the manifold will reduce temperature only on this one particular manifold. And now, if we save the project and calculate it again, we will first see that there are two values of supply temperature. And to be able to find out which one is the mixer and which one is the mixing unit, let's just assign some symbol mixer. And let's do it again. And now you can see that this is supply temperature for the mixer, so for these three manifolds, and this is supply temperature for the fourth manifold on the mixing unit. And you can change the supply temperature right here, or you can just click on this element on the drawing and change it right here. This is for the mixer, and if you would like to do it for the manifold, you can click on this manifold and you can also change it right here. So if you have more manifolds with mixing units, you can do it directly on a drawing by selecting element and changing supply temperature. So this is the first parameter, supply temperature, and two other parameters are right here in this window. It's called interactive radiant systems calculations, and there, for each circuit in the project, you can change temperature drop or pipe spacing. And for example, if you increase it and calculate it, you may observe how it changes all other parameters. We have increased temperature drop, and in return we have reduced heating output. And same with pipe spacing. So I hope that now you know how to change crucial parameters and how they affect results. So we may go to last stage of this tutorial, and finally we will make some final corrections of the drawings and prepare drawings for printout. Let's take a look on the drawings again, and let's make some final corrections. First, let's take this room and let's spread a little bit the pipes inside to cover more space. I will change pipe spacing to 175, and let's check result after calculations. Okay, and now we'll take one single loop, maybe in this room. If you click on this tab, loop drawings floor, and if you select the floor, you will find hot point, this purple arrow. By holding this hot point, you can move it up or down, and this arrow indicates direction of the spiral inside this room. If you grab it and move it up and calculate it again, you will see difference in arrangement. Now it goes up, turns right, and so on. Finally, if you would like to make some manual corrections, first you need to uncheck some particular loop from automatic drawings. So you need to uncheck this checkbox, and if you do it, you will be able to modify loops in the room. And for example, let's say that I will delete that section and I will extend these sections a little bit and draw the last remaining part, the last remaining section between them, like this. And after calculations, you'll see smooth curves here, not so sharp. When you make some manual corrections, you can also use, to do it more precisely, grid mode, this one. If you switch it on, you will see some dots, and you will be able to, using the smaller or bigger dots, to move sections or points of the loops more precisely, to maintain same distance between them. That was loop, and similar situation we have with pipe fits in this tiny room. Now we will decrease a little bit the distance between these pipes. And using that one pipe fit, I will manually draw it inside this room to cover this empty space. To do it, first I need to click on this section of pipe fit route, and with right mouse button
choose function enable manual arrangement of pipe fits. Program informs you that if you switch it off, if you switch off the auto mode, program will no longer be drawing the pipe fits, and also this automatic tool that divides heating zone will be switched off. I confirm with OK, and now I can click on this section and, for example, I can delete it, and then I can take single pipe run, start from this point, and I can draw it manually just to fill that empty space. I can do it roughly, or again I could use also grid mode to do it more precisely to maintain the same distance between these pipes. And again, after recalculation, that sharp curves will be smoothed. Now it looks much better. And we could do in the same way some improvements in other places of this drawing, but we will skip it. And now let's assume that the project is ready. We have made all required modifications, we accept the result. And finally, what we can do, we have two options or three options now. We can export the whole model of installation to IFC file. We can export drawings to DWG file. There you can control the settings. For example, you can decide if each level, each story will create another separate DWG file, or all of them will be exported to one DWG file. If you would like to print drawings directly from the program, or if you would like to export it to PDF file, first you need to insert page layout. There you can see data of this page. And first we will change the paper format, change orientation, and we can also change scale, set margins, adapt frame of the drawing, and so on. We will put here also drawing chart. And you can fill it with text by entering these fields. And we can also add some more graphical information. For example, we can display parameters of each manifold. And this is example of manifold 4. You can see all parameters. You can see pump unit, supply and return temperature, mass flow rate, and parameters of all circuits connected with this manifold. And we could put on a drawing these charts for each manifold. And we can also, for example, add another drawing of floor buildup. It can be 3D drawing or two-dimensional drawing. And when it's ready, you can check printout window to check it before printing. There it is. And finally, you can export it to PDF file or just print it. And that's all what I wanted to show you in this tutorial. It's quite long, but remember that you've got links to particular stages of this lesson under this video, so you can use it whenever you want. You can quickly jump to the right stage of this lesson. I hope you like it. You can add some comments under this video if you would like us to show some stage more precisely, or you would like to have more information about some of these stages. So please add some comments. And that's it. Thank you and bye bye.